Hey everybody, acid-base indicator lab. Here it is. Check it out. We're gonna do this. Lab today. Indicators. You're gonna tell me what an indicator is, and we learned earlier in the unit that it's a special chemical that's gonna change colors with pH and that kind of thing. So you're gonna tell me what you can about indicators. Background. I have two unknown solutions, and you're going to be able to tell me the pH of the two unknown solutions. You're going to guesstimate a good range. Okay? Procedure, I'm going to go through that right now. And there's some pieces ahead of time that I want you to do. So this is your actual data table. All right? And I was not very clear last year, so I want to change some things, and I want to make sure everybody gets this right. So this is what I want you to do. The first sample, notice left-hand side is all sample 1. Second side is all sample 2. So I want you to run one sample at a time. Okay, and you don't have to clean up in between runs. We just want to not run both and get confused. So we're going to run sample 1 and then sample 2. If you want to run sample 2 first, I really don't care. Just make sure you put the data on the right side. And before you start the lab, this is what I want you to do. I want you to go to table M in your reference table, okay? And I want you to say on methyl orange here, I want you to get the range down. So it says 3.1 to 4.4. So I want you to make a good mark at 3.1, and I want you to make a good mark at 4.4, okay? And then it says from red to yellow. So you know on the left-hand side it's red, and on the right-hand side it's yellow, right? And in the middle would be orange, and there's not a lot of room, so I'm going to put an O. Okay? I want you to do that for every one of these. Now, of course, this methyl orange will be the same, but the second one down here is bromothiamyl blue. So I'm going to have to, put in bromothiamyl blue's range, mark the range, and what the colors are. Okay, and that's going to help in the long run here. So then there is what I actually want you to do. So notice indicator solution 1's got a 1, the beaker's got a 1, the pipette has a 1. I'm not sure how well you can see that, but they all do have 1s on them. And the 2s all have 2s on them. So we're going to keep them separated. Oh, wait, nope, put a 2 on the pipette. Come on, buddy. Get your act together. Okay, now there's a 2 on the pipette. We good now. Okay, we're going to keep them separated. And then this is another key piece I need to do. So phenolphthalein is super sticky. So I don't want you to test phenolphthalein on the clear guy. You can use this for everybody else. I need you to use the ceramic piece for phenolphthalein this year. I'm going to hope that it's not as sticky. Okay, because remember when we were doing the other lab, when sometimes you put water in here, or, the chemical in here, and you tested it for precipitates and it would turn pink? Well, that was that phenolphthalein sticking around from last year, and it's mad sticky. So I got some brand new gel plates, never been used before, so we shouldn't have that problem. I want to keep phenolphthalein off of these. Cool? So we're going to use the little ceramic guys just for the phenolphthalein. So I'm going to take solution 1, say, and I'm going to go ahead and draw some up, and I'm going to go 4 wells, pop, 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 and 1 well into here because I have 1, 2, 3, 4, 5 indicators that we're using. And there are the 5 indicators. You see them? They're all labeled. They all have the parafilm down, trying to keep them from drying out as much as possible. Okay, so I want you to keep them as pristine as possible. And notice the phenolphthalein looks very familiar. It is the same phenolphthalein that we're using for the titration lab that is still up and running. So now we have to share between titrations, and we have to share here. And sorry about that, but I just don't want lots of phenolphthalein. It does really dry out fast and leave a residue. Okay, so this is what I want you to do. I got like 4 drops, 5 drops of each in one row here and 1 here, and I'm just going to go ahead and let's do methyl orange first. And I'm going to put methyl orange in there, and I'm going to do all the. You can put them in order if you want. You can do them all and then write your data. You can write your data after each one, and that's fine with me. So I put my methyl orange in there. And let's just say, and this isn't, I'm making this up because you're not allowed to copy data. I put my methyl orange in solution 1 and it comes up yellow. What I want you to do then is box in this range that is yellow. That's if it's yellow. If it was orange, you got to box in the middle piece. If it was red, I want you to box in the part on the chart that's red. Okay? And I want you to box this in because if it comes up yellow, you know that that's greater than 4.4, but you don't know if it's 6, you don't know if it's 10. See what I mean? It's somewhere in there. And here's the way the lab works. After you've done that for each of these, you're going to be able to narrow in, hey, whoa, hey, look, most of them match at about this. Where you get the most matches, that's where you'll guess for the pH to be for sample 1. The procedure for sample 2 is going to be exactly the same. You will have your ranges all pre-done. I would not rinse these because you have your 4 here. You can do 4 here and use the other side of the ceramic to do solution 2. I would just do all solution 1 first and get your data, and then all solution 2 and get your data before you rinse. And then they can go right in the drain and rinse thoroughly and leave to dry for the next group. And we can probably get 2 or 3 groups going at a time, maybe 4 tops. But we're probably going to use this front desk as the actual lab station. But I haven't decided. It's just because the rest of the class is still dirty from doing ice cream, and there's a lot of makeup lab stuff that I haven't put away and back because I've been trying to get these other labs up and running right and get these solutions right so the pH is just perfect. So that's that piece of the lab. We're going to block in the pieces that match up the colors so I know what pH range that particular sample is based on that indicator. And if they don't all match up perfect, you're probably still going to get 4 out of 5 or 3 out of 5 that line up where you can predict what the actual pH is. Okay. Then you have some questions to answer and to calculate your pH. And you are going to have to put that into concentration. And there's a little bit in here about the logs, remember? And what we do to say, well, the pH 5 is negative log of x, which turns into 10 to the negative 5, remember? We did this in the POGL. So then that goes to 1.0 times 10 to the negative 5, or 0.00001 molar. Now that's an example if the pH was 5. If you pick a pH of 8, then it's going to be 10 to the minus 8. If you pick a pH of 4, it's going to be 10 to the minus 4. So that's what's going to help you figure out these answers here, and that's how that works. And then, of course, you have your CEI, your claim, your evidence, and your interpretation. Purpose. Claim. Solution 1 has a possible pH range of blank to blank, classifying it as an acid or a base. Right? Same thing for solution 2. Cite the data you collected for your evidence. Cite the data you collected and how the combination of your indicators helped. So especially the ones that match up. If there's a flyer, you don't have to talk about that here, but the ones that match up, talk about the ones that match up. Then the interpretation, use the possible pH values to estimate the H plus concentration and rank your solutions by their concentration. Which one has a higher pH, solution 1 or solution 2? Okay, that is the indicator lab. It's kind of cool. I hope that you get to see some of these indicators change colors and get a feel for what's what and how to use these indicators. I will let you know that one of these solutions is an acid and one of them is a base. So you should get 2 different results, and that's why we don't want to mix them up, but you can use the same well plate again as long as you stay in the row. So you can use these 4 as solution 1, go down here and use these 4 as solution 2. Okay, and if I use this as solution 1, I'm probably going to use this one over here as solution 2. Makes sense. Keep them as far apart as possible. Got to keep them separated. And that is indicator lab. So with that, I see you tomorrow in school, and good luck.